Okay, good afternoon, good evening for some of you. Thank you for joining us on our new session of our Bridge Special Interest Group meeting. Today we have the pleasure to present to you our new development, our latest development that was done on this release of OpenBridge Modeler and also coming on the release of OpenBridge Designer, and is the option to use parametric and functional components to create your custom bridge elements. So what is these functional components or parametric cells that actually we were announcing for quite a long time? So the idea to use a functional component is something that existed already in MicroStation, right? That we also call it parametric cells. So you create actually a 3D, 2D parametric cell to do or to create elements that you know that are going to be changing in dimensions, for example. And then you don't just want to do it every single time. So you want to try to do it as parametric as possible, right? Now, the Connect edition give us this extra option to do these parametric cells, but then at the same time, connecting these cells to the software itself. So not just as a MicroStation 2D or 3D element, but as well as connecting to design, reacting to the design. So not only becomes parametric, but then the full name is functional components, right? So meaning that you can create a parametric abutment, but if this parametric abutment is going to react as you move the deck of your bridge, oh, the abutment will move. So it's not only parametric, but now it's functional to the bridge. So that's the name of functional components. Now, how you do this, right? Is going to answer all your needs of a custom element. Well, you just need to evaluate it first. What you can do or for what's the purpose of creating this functional component. You know, maybe you cannot do it all with the tools that we already have in OpenBridge. No, you cannot do a variable cap or a variable column element using our existing tools, existing dialog boxes. That we provide a great deal of parametrics, but sometimes there is just that type of structure that you cannot cover. So then you will say, yeah, I need to build a functional component using OBM, OpenBridge Modeler. So when I finish building that, well, if I want it to be pervasive to all my users, I want to put it as a part of a workspace. So what you do is as you create this functional component, actually it's a cell library. Actually it's a cell. So you can put it on a cell library and just can deploy it all across your organization like any other cell library. It happens to be that this library is quote unquote bridge intelligent, right? So after you deploy it, well, you just use it, right? And you can make it as parametric as you want, right? And then when you want to use it in OpenBridge, there is nothing special, just to select the option that you want to place custom element. So you remember we have place peer, place abutment, but there is also an option that says place custom, and that is where you are going to select the cell libraries that will contain your functional components elements. So how you do that, how you start thinking how we're going to create this, right? So yeah, I want to do it parametric. So maybe thinking, okay, after all of this structure, this is the dimension, for example, that is going to change, right? But thinking of that, right? Remember, if I want just to modify this dimension up and down, right? So what happened with these lines? Are they going to be remaining the same, right? So if this goes down, should this line move? So you have to think on these major or minor changes that you're going to do in your structure will affect the rest of the elements. So start thinking first of a 2D section and how it's going to behave, right? So then when you establish that behavior in a 2D cell or a 2D element, so then you will extrude it, right? And it will become a 3D element. Then you provide more of the parametrics and you will just create the cell, right? So first is draw it in MicroStation, the elements that you need, right? And then do the extrusion in 3D, right? And see how these dimensions will change. Think of that first before attempting to do anything, because then you will express your design intent. Now, remember, this could be your cross section, right? This could be your 2D element, right? And then as you extrude it, well, it becomes a full-blown abutment, for example, in this case, right? And all these markers that you see, it represent, and that's how you will create these parametrics and behavior that will represent the constraints that you will go to the individual lines to how they're going to behave when some of the numbers may change. Not only that, you can change numbers, but for your standard user, a number may not mean much, right? So, because actually he wants to change maybe the height of the cap, the length of the cap. So, to any dimensions that you apply, you can also associate variables to it. So when your user is going to apply this custom element, he doesn't need to think what is dimension, for example, here, D1, D2, D3, and start typing the variables here. It better be served if you, when you create the cell, you call it width of the footing, length of the footing, height of the cap, length of the cap, right? So he just know, oh, that's what I need to enter. Here to me, it's kind of cryptic to say D4, D5. So you have to be careful on how also you define all these variables and constraints, right? So after doing that, well, we give you more options into OpenBridge, right? Because what you can do is after the solid is done, right? When you think about it, this is no much than a 3D solid element in MicroStation, right? So what we need is these 3D elements that I created that are fully parametric, how are they going to behave? Is that part of a bridge or is just any other MicroStation element? Well, we give you the option in OpenBridge Modeler when you create these cells to assign a tag. What is that? That, well, if for example, if you see this 3D cell, if you leave it like that, it's just a 3D cell, okay? On the other hand, this solid, right? For example, you can tag it. So just basically associate it with a bridge element and says, oh, this is a cap, right? So what does it mean? That then later, when you report quantities, when you report elevations, it will report that volume of concrete, for example, because it recognizes that it's part of the cap, right? If you draw a custom pier and you tag it certain parts of that as a column, so then when you report column quantities, that custom pier that you created, part of the elements will be computed as concrete because you tag it as such, and also the other elements, the top solid that goes on the column, you tag it as cap, so the software will understand that hey, that solid element on top of the columns is the cap of that bridge, right? So this is what we call tagging, assigning a tag on every structural element that you generate. Not only that, we also call variable mapping. So what is that? So if I go back, for example, right? If I go back a couple of slides here, right? So I'm creating this length, right? And this is the length of the abutment right here. So if I have a bridge of different dimensions, what length should I set it up? 20 feet, 30 feet, 42 feet, right? So I have to type the dimension. And then the idea is that in these parametric cells, yes, I can type the dimension, right? I'm trying to measure it. Oh, it's 42.3. And then, oh yeah, it fits the length of my deck and it accommodate the beams, so it's good. But what about, right, if we don't do that and we just say, hey, if I'm going to do this, variable map it. So my variable, remember that you define variables, my cap length or my D1, right? No, better, cap length. My cap length that I define, I really associate it with a variable in OpenBridge. So then I don't need to type that quantity or that dimension, I'm sorry. I just connected directly that the OBM cap length inside the software is associated with my cap length in my parametric cell, in my functional component, right? If you are going to do a slope cap, so what slope should I enter in my user variable? 2%, 2.5, 2.34 because it's in super elevation? No, I associate my variable slope length to the OBM cap slope that is defined inside the software. So as it's computed, it just enters the elements right there immediately. So that is the advantage of associating your variables to other people variables, to OBM variables, I'm sorry, right? So now, so far, what we have exposed to our users is this cap length and cap slope. So you can match these two internal variables, you want to call it like that, to the user ones. Of course, more and more are coming. This is the first introduction of our tool. So your feedback is almost, it's also more than welcome. So now, as you do that, right, and make it parametric, assign tags, and do all the variable mapping that you can, now the next step is just to use it, to place the functional component in OVM. So how you do it? We just go substructure, place custom, right? In this release, we have functional components available to place piers and abutments. Uh, so basically only substructure elements. Later will come super, right? And then as a user, you just adjust the variables on the fly, right? And just type the dimensions. You will see your cell changing, and then you just place it as you place any regular pier or any regular abutment. As becomes part of the bridge, right? Your quantities reports will get updated. And later we can even incorporate it's in the works to do pro concrete or pro structures detailing inside the pier. So it will come already with these elements associated. So it becomes part of the bridge. So it's, remember, this is not just placing a 3D cell, right? It's just actually placing part of the bridge. So for example, if you place it, your pier along a support line, right, as you have to do, and if you move the support line, if you skew the support line, the the parametric cell, the functional component will move. In this release, we provide multiple examples, right? And these are the examples that you can actually uh, place, uh, play with it, modify variables, edit it, right? That is the location inside the software. So that cell library that of these functional components are by default in this folder inside the program data, OpenBridge folder, under functional components. So these are basically, these are just microstation cells that are parametric, of course, and then you can just modify it and then research the properties that they have inside. And obviously being on a cell library, you can just place it in your workspace and so then everybody can use it. These parametric cells that we have are actually uh, PennDOT, Pennsylvania DOT custom structures that they use for the abutments and for the piers, right? So to give you an idea, this pier that is right here, we cannot do it in the standard OBM dialog boxes, right? So the only option was to do this using parametric cells. So this is the elements that are on the library. And then here, this is an example on how you can use it, right? So this parametric cell was created using all these variables. And then, don't get me wrong here. I mean, we set it up in this in such a way that it will try to accommodate every single variation of the library, from the cap all the way to the piers. Um, but you don't need to do all these variables unless you really want to make it fully parametric. So don't go overboard on trying to define every single element as parametric. Do it as practical as you may consider your peer in this case will change. Uh, Also, on the other hand, when you define this, you go all the way, meaning that if you select that you are going to do these parametrics, right, you have to define the entire element. So, meaning that, oh, yes, I'm going to do this. So you have to take care, in this case, of the substructure, from the cap all the way to the pier layouts. You cannot mix and match with the tools that we have. Oh, I do the piers parametric, and then the piles, I will use the dialog box. It doesn't work that way. So it's you have to define the entire uh, pier structure uh, with a parametric cell if you want to do that. You cannot mix and match the tools. And as you can see, when we have done this, it becomes fully parametric. So you can do, if you do it or parametric enough, so these inclined piers, it could be easily converted in a two-column straight pier, two straight column piers, right? So, but again, as you see, it doesn't check that when you move this, it's that column is not going to work. So it's just a modeling tool for you. So, and again, all these parametrics were included into this particular pier that basically achieve all the case scenarios. And it doesn't warn you that, oh, this column is almost going away from the footing. So you just have to double check your work on that. So there is no error trapping scenarios achieved on that model itself. See? So this is all these elements, or this is all these options that you can apply. And then when you create this, again, it's, as I said one more time, it's up to you to make it as parametric as you want it to be. Okay, and that is the case for a pier. Now, you want more of a complex scenario, well, take a look at the PennDOT abutment, in which this is a very detailed configuration that they use, and the behavior of the wing walls. And on this one, they were smart because they say, oh, the wing wall it moves at the different angles. So rather than creating one case that address everything and maybe making it more complex, that same abutment type, because of the different behavior that the wing walls do, so they separate into different cells. So they have one cell for a certain degree angles, and they have another set of cells for another degree of angles for the wing wall. Placement is the same, it's just the constraints were too much, so they were able to separate into two. So they have two cells that look the same, but the behavior is a little bit different just because of that wing wall angles that they have. So yeah, you can test the parametrics. So now how you place it, very simple. You just go right to the place custom. Let me redo it again. You just go to place custom to place it, right? And just select it. So let me go back a little bit more. Here, you go place custom right here in OBM and just select from the library the ones that are parametric. And these are all the variables that you can change and place it. It comes with default values, and then you place it as any regular element in OpenBridge, you know, the scale, the rotation, the offset. So it, it's just your regular peer placement. But then with the difference now that, oh, I have to move it to the proper location, I may need to adjust the flanges. So now you will go to the element properties, uh, right? Or what we know the info, right? Remember for the on B8I we have the element information, same thing, right? And we can just start editing these variables. So you can go edit the cell or just select on element information. So as you go there, now you see now all these variables being exposed. And then that's how you start changing that structure according to your needs, right? I want an angle of 15 degrees, then my footing length needs to change. So then really you can take advantage now of all these parametric cells. And there is no need to redraw or do anything extra in MicroStation. So you take care of that, then all these options, all these variables that you expose are just basically ready to go. See, and then again, you can make it as parametric as you want. So this is how you place a custom cell on that, right? So now, seeing the usage, let's go very quick and review how this is done. So this is how you can create actually a parametric cell. Oh, this is how you place it, right? And this is the one that we created. And that's how you place an abutment one more time. And then you just place all these options and elements here. So this is basically another example on how you place this, right? Now, how you create it really on the fly, right? Or new one. But before doing that, I have to just give you the limitations that we have. So don't think of that this is the solution to all your problems, right? I mean, it will solve most of them, I would say, right? And you can make it as simple or as complex as you want it to be or generic. So, and it's only for substructure first, then later will come the superstructure, right? So my point is, don't make it overly complicated, please, right? At this stage also, if you want to do the excavation tools, remember that we have that excavation under the footing. We don't do that yet, right? I mentioned as well that there are only two mapped variables that you can consider up to this time, right? And then as not as being reactive as the ground. Remember where we say, oh, 3 feet below the ground, 6 feet below the ground for the footings, you have to adjust it that according to the parametric cell, right? So as I said, these are the limitations that you have so far. And then it solves at this stage, I would say, just uh, the limitations are just on the analytical side. So this time, these elements that you model, right, are not transferred to analytics because they could be so custom that i- we we didn't implement it yet. It's on the works as well, but there is no. It's just solve, I would say, your modeling needs. Later we'll come to do the analytics. And there is no automated drawings. Of course, if a 3D solid model, you can cut cross section or slices, but there is no the ability that will say, oh, this is a substructure and create a sheet for me. So, but it can certainly be used as part of the 3D element, right? So saying that, let's see how this is done very quick. So as I said before, you just start with a 2D drafting, right? So you start drafting this and you can get use of helping lines, of help lines as we call it. So because that will encompass the elements that we are going to generate. Also I use this slope line because remember my cap, I will like to rotate according to the super. So I will use this element to adjust the rotation too. So then I just start drafting in 2D, right? The lines that they're going to follow. So the top and bottom, and then I start creating the piers. I encompass this area because this is the all the elements that I will select in one shot to move, and as well as in the bottom. So then I start. So I establish the constraints. What is that? Meaning how these lines are going to move. So for example, this point will be fixed according to this line, right? And then some elements will be, as they move, it will be always coincident with the elements that are attached to. So element by element, you will be attaching options to say, oh, if this line move, the other line that I select needs to move parallel with that line, or it needs to be perpendicular to the line, right? So for example, if I change the length of the footing, so the length of the footing, I change it at the bottom, right? What is going to happen with the top? Oh, it has to move parallel to the bottom of the footing. So these are the constraints. And these icons show you that this is going to be the angle. It always will maintain this angle, right? And it's just selecting elements and establishing these constraints right there, right? So, and then you just keep going, selecting all these constraints, right? Now, so, and this is the part I would say that you have to really think about it, how the lines that you're placing or how your peer, in this case, will behave. What's going to be parallel to what is going to be perpendicular to what is going to be rotated to what, right? Or how they're going to behave equal to each other. So this is the part that you just set it up and how they're going to move, right? And also these auxiliary lines, you see, everything will be parallel to that. So you have to really think that process. To me, personally, that will be quote unquote the difficult part, right? In which you have to really think how is going to be the behavior of if I change one number for one line, so meaning a number, a dimension, what's going to happen with the rest of the elements, right? So this is the part that you have to really plan how it's going to behave, and then to each line you will add variables, right? Or rotation, right? So how this is going to rotate based on dimensions too. See, so and it's going to be coincident to all these elements. So now after you keep placing this, later you will see that you will start changing dimensions, and then you can double check if that variables that you enter, you see how it's moving parallel. So if that variables that you enter and their constraints are behaving the way you plan it. If not, you have to delete each one of the markers and reconstrain it again, right? And then also not only the behavior of the element, but also the distance that you're going to use. So there are not only constraints on uh, connections, right, perpendicular, parallel, coincident, but also restrictions in distances. So you can put what is called dimensional constraints. So these have to be the same distance as the other. This has to be, well, not the area, but I would say mostly distance and angle, especially you're doing super elevation, right? So one distance will become equal to the other, so on and so forth. Okay, so then you keep going with this definition, right? So now you start placing all these definitions. Now these we are recording in YouTube, in our YouTube page. I will direct you to subscribe to our Bentley OpenBridge channel in YouTube. We are posting a whole training video. It's a 25-minute video on how to create all of this step by step with instructions, so you will see the whole length of the video. This is we're just showing you here more or less the basics on how this is done, right? So this will be the 2D constraints as much as you want to apply it, right? And then the next step, as you test all of these dimensions, right? As you can see, it could get quite elaborate and precise, right? The next step will be to say, okay, now I need to extrude these elements, right? So you apply solid by extrusion, and that's the one that it creates actually that pier, that cap, and all these elements and how it's going to behave, right? So then you have to use then the solid by extrusion, the solid elements in Bentley, and then also the modeling tools to cut chamfer, for example, and all of that. So this is what the extra work in 3D that you need to do. But contains all the constraints that you have on, on that, right? So this is what you need to do on the extra constraints and how the extra behavior is going to be. And then after that, just to accelerate, then you just place the abutment or place the pier as you see before, right? It's a cell, so now it's just a matter of attach it and then do it, right? So this is how you place it at the end. So as I said, this full-length video with sound and instructions, as I said, is going to be included in our Bentley OpenBridge page. So I will encourage to wait until Monday. We're going to post it for today, but maybe Monday if you can access that. Um, so today is June 13, so yeah, by the 16, 17, it should be just right there. And then as you can see, you can change all these dimensions. So this is for the substructure, piers and abutments. And then in future releases, we're going to be considering to do the substructure, superstructure variation, right? As I let the video running for you to see, we start answering questions now. So yeah, Carl, I thought that Bentley decided to phase out tag elements in MicroStation Connect. The tag commands are no longer available in the new GUI, and you could say that item types properties are the replacement. You're right. I mean, but then these tags that we're talking about, right? It's, yeah, I mean, you're right. For a lack of a better name, right? For lack of a better name, we do it tags, right? And yeah, I remember way before it was not only tag, but it's also called data elements too, and tags as well, right? Yes, this is now being used in MicroStation Connect. Then item types what was its replacement, right? And item types it's that, but the difference on this is that we call it tag only inside the OpenBridge environment because we have to attach it to a behavioral element. So this cap that you see here on the screen, for example, that I said tag element as cap, is not a tag that I created. It's internal in the software that it will dictate the behavior inside of that solid inside the software. So it will compute the quantities as such. So it's more of accessing the inside of the program to see, oh, this solid cylinder that I created parametrically behaves like a column. And that column behavior, of course, is inside uh, OpenBridge Modeler. So yeah, maybe the tag name is a little bit confusing, but this is completely different as the tag that we used to have a long time ago in MicroStation, right? So that I hope that answers your question. Is it possible to place tangent radius such as chamfers? Yes. Yes. Remember, this is what you create is solid elements, right? So then when you do that, your solids will become, you can just manipulate the solids and create fillets or chamfers too. So this is no different as creating a microstation solid or in OpenBridge Modeler, with the big difference again that the elements that you use it, you are making that elements fully parametric. So you have all the options available for on the MicroStation 3D solids there. Yeah, Russell, when will be two-way slope be available for variable mapping? Yeah, that requirements is uh, very popular down under. So it's we have to do it first on our side, not only on the parametrics, but also on the regular OpenBridge modeler. But this is something that is as part of the roadmap, is part of the enhancement that they have requested, especially for other markets, like the Australian market, for example. Right. So, but it's part of there. Right now, what we have on our caps is only level slope or matching the slope of the deck itself. But if it's in crown or two-way slope, so we don't have it yet. Okay, but it's getting there. It's getting there, Russell. Thank you. Any other question? So one question is, when is that available? I mean, this is available right now. Okay, if you have a license of OpenBridge Modeler, right? The modeler only, yes, it's available right now. You can start using that, playing with it. On the other hand, if OpenBridge Designer hasn't been released yet, so uh, it's going to be pretty soon. So it's going to be the 10.07 version and ahead. So on that is going to be included all these parametric cells. So just wait a little bit until the software is released for OpenBridge Designer. Okay, so you have that license, so we have to wait a little longer on that. Uh, Obviously, we're planning not only to do SIG meetings, to do it's this is recorded, so it's going to be part of the Learn server. We're going to include just the video of the training, as I mentioned, in our YouTube channel. And also, we're planning to write a full manual, a full training manual, a PDF document on doing that. Right? So, we still have some questions coming. Yes, yes, yes. The link to the sync videos will be provided. Yes, you're right, Patsy. Can we have the presentations? Well, it's going to be part of the Learn server, so you're going to have full access not only to the presentation itself, but also of the recording of the whole session. Well, on the full recording, you can get the PowerPoint, I think. Yes, sure, sure. And we can enhance it more. We need to add more stuff on the PowerPoint. I think, I don't know if they're going to be last minute changes on development too. So we're planning to give you guys the latest and greatest on that. Right. And also, if what you can do as well, right, is to invite you. I mean, we always have, I mean, these all these updates that you see on the SIG meetings and all of that are previously sent. And then you can actually um, connect to us on these sessions, right? Um, so just I encourage to connect to us, maybe join our sessions on the uh, Ask Alex or Ask the Experts as we do this, right? So just subscribe to us, alex.marriage@bentley.com. Send me your email, and then this is the link. So every Thursday at 11, either Raul, Steve, or myself, we're conducting these half an hour updates on what is coming into the software. We're sharing our experiences and so on, uh, tricks and tips that you may want to be updated of, right? So just send me an email and we just uh, connect to you guys, right? And yeah, somebody asked me for the link. Yeah, this is the link, but then to receive the invitations and all of that, so you can please subscribe. Send me an email, so I just put you on the emailing list to so you can connect. But the link is being used every day. It's being used in every session as we're trying to conduct it as every Thursday as possible. right? So, but just subscribe so we can have you on the list. Like for example, next week is not going to be one because we are traveling everywhere. So, but the week after we will have it. So we announce it actually every Thursday early in the morning that yes, we're having the session, so you're able to connect for that half an hour. Well, if you're going to use pro structures to do these sections, right? I mean, you got a parametric, and that's a valid question, Benoit. So you have a parametric cell, a functional component peer, right? And you want to create this with pro structures, yes, you can do it. Because remember, at the end, what we create with these parametric cells are microstation solids, right? And pro structure can detail any microstation solid whatsoever. So, and it's attached to it. So it doesn't need to be created with bridge. Actually, you can create anything with microstation and detail it with pro structure. So the functional components isn't going to be any different. At the end, we just create a microstation solid. The only difference is just part of the bridge. That's it. Okay. So any other question? I think one last one. All right. So that's it for today. Thank you so much for joining us. So remember, keep in touch. Our YouTube channel is 24/7 available. So OpenBridge, we're adding new videos on OpenBridge, on LibBridge Concrete, LibBridge Steel, and RMBridge. So just keep in touch and then see you online. Thank you so much.
If you found this video helpful, please give it a like. If you want to see more such series, consider subscribing to our channel. Thank you, and see you next time.